Okay, let's go to device driver and some leftovers that we did last class. For registered Canada we have to do. The major leftover was to create the test script. In which we have to do check-in function. Now we have to write the main menu function, which will be written like this. In this function we'll write what we are going to do, as in various operations with the driver. Change mode and start the script. In this main menu function we have to echo the main menu, write the main menu, options will be number 1 check-in, एक मिनट रुकना, दूसरे कप से दो, नहीं दे दो, और ये वाली लाइट ऑन कर देना प्लीज. check-in, checkout. This script, so you will be familiar with this script. Then after that we have to do checkout for build. Then we have to do ins mode, insert driver. Then remove driver. Then after remove driver we have checkout for development. That's all. Enter your choice. ठीक है. Read. Read. Enter your choice, but before that you give the prompt. And when it comes to enter your choice, -n1 means take only one character. That's all. तो चॉइस तो आ गई चॉइस वेरिएबल में. Call it choice variable. मेन मेनू में ही सारा कुछ हो गया. अब ये सारे फंक्शन लिखने पड़ेंगे अलग से. पहले चेक इन फंक्शन. In check-in function, you'll write the for loop. For where in ls star dot h dollar ls star dot c do done. Here we have to check in $var. Okay. Similarly, we have to check out this will be h comma v and c comma v. So I've started taking tea after coming back from Rishikesh. I'll take it till March end. Now checkout भी हो गया. अब हमें करना है insert driver. Insert drv. Here we have to do ins mode. Ins mode. The driver dot slash modules slash driver का नाम क्या दिया था बता सकता है कोई? CDD something बैच नंबर होगा शायद 150 है ना? Dot q. So this is done insertion. After ins mode, we'll do ls mode to see what are the driver inserted. Let's use the read call, which will just cause the insert driver function to stop at the read call, so that you will be able to see using ls mode that what are the drivers already inserted. Cat slash proc slash हाँ लिख सकते हैं. Okay. Again read so that you stop. Then cat slash proc slash modules read. This will display the modules and that's all in display in insert driver right now. After that, your function remove driver. Remove driver. In remove driver, we'll do rm mode cdd 150 followed by same 6 commands. Okay. Then you have to do checkout for development, in which you will do checkout for development like this. Checkout dev. Where the checkout will be done using -a. Yeah, who is that? Okay, now we have to use a case statement here. Case choice in first case will be 1, in which you will call check-in function. Followed by break. Second case is 2, which is क्या था? Checkout. So name of the function was checkout. You have to call this function checkout break. Case 3. Case 3 is insert and insert drv. Name of the function is insert drv break. Choice 4 is remove driver, remove drv. Break followed by case 5 is checkout for development, and name of the function is checkout dev. Break. That's all. जरूरत है इंसर्ट करने से पहले तो बिल्ड करना था, मिस कर गए, we missed it. Build driver. Build drv 4, 5 and 6. ये ऐसे क्यों है? हमने केस को खत्म नहीं किया ठीक से. This will be case over. So build drv function also has to be written. Build drv function, in which what we have to do is if make, we have written the make file, then else fi. We will say build successful, but there could be some warnings also. Read -n1 -p build successful, full stop. Do you want to insert driver? Sometimes build will be successful, but then we'll have warnings, and then you have to make a decision to insert or not. If your reply comes to yes, then probably you can insert. No, you can go ahead and insert. Insert function will be called from here. Always from here. But we have given a separate function for it, isn't it? So build successful. Okay, remove it. Just give the read, क्योंकि हमने तो मेनू बना दिया अलग से. Make it echo only. Just give the message that yes, build is successful. So we have changed the architecture of this. Simple messaging है. simple intimations. Okay, that's all. No, क्योंकि हर बार when you do modification in your code you have to do check-in also. Okay, so here we are. I think everything is ready now in this test script. Let's run this test script. I think all the files are closed because we are doing RCS now. This is the test script where we do number 1 check-in. There is some problem. Okay, this will be dollar choice. Test script. I enter 1, and it goes into check-in function. Enter your choice. We have to do check-in for decorations.h. Let's go in decorations.h. This documentation becomes very important. So we have done the licensing and giving the name and the major number. Gave license information. Declared macro major number and external variable major number. That's it. File operations.h. This header file declares kernel data structure for describing mappings for system calls to driver routines. See this documentation for this RCS device driver. I am writing, some brief, and I'll not skip it, even if it takes time. The reason is this will using rlog. I'll create the documentation and make it available to you. Okay, using this you will be able to understand that what you have to do in your device driver. Okay. Right now it is just declared and there are no mappings as such. Okay. Then you have headers.h, in which we would have declared some header files. Init modules in FS. This declared included linux/init.h modules.h and fs.h. Remember, in this order does matter. Okay, don't change order, keep it as you see here. Next is clean.c. Just let us go inside clean.c. There. In clean.c we have just unregistered our device driver. Okay, using unregistered Canada. this is the module cleanup function. It will be responsible. It will be executed when removing the driver from the kernel. It will unregister the driver using unregister_char function. It will do everything, insert the initialization function would have done, but in the reverse order. Okay. Then we have written the initialization function. There it is, in which we registered the device driver using registered char. This function is used to register the driver with the kernel and make entry in the device table. It will also be responsible for initializing the hardware device. We registered driver with the kernel using register char. Okay. Then displayed the major number using print k, where print k is a symbol imported from kernel symbol table. Right, that's it. But the problem is, why did the script end after this? It should have gone back to menu. That means we need to put it in loop. Isn't it? This should have gone in loop. And why did we put a main menu function here? We should have put it. Are we calling main menu function? Oh yeah, we are calling main menu function. So this call to main menu function should be in while. Keep it true forever. And then you put in an extra case also here for exiting. 0. Exit test script. Give exit and the exit code. Run. Syntax error. There it is. 1 for check-in, everything is already check-in. 2 checkout for build. Checkout for build has happened. We checked out the declaration.h, file operations.h, headers.h, clean.c and init.c. Then number 3, we are going to build our driver 3. The driver build has started. Okay. It says you entering the directory because the make was done using -c and the build is successful, no errors or warnings reported, build successful. Then number 4, we are going to insert the driver. The driver has been inserted and you see ls mode output is here, cd150 is in, press enter. It shows you the device table. The driver number is 238, CARDAV 150 is the name we have given to our device driver. Press enter. It shows you modules, the list of modules, active modules in your kernel right now. The active modules in your kernel, the top of the stack you have your device driver at this address, output enable, and nobody is using it right now. Then we are back to the menu. We have done with the testing of our device driver, so we are going to remove our device driver from the kernel, choice number 5. The device driver is removed. Don't forget and become lethargic to check it. You have to check it from every place. You have to check it from device table, 238 gone. You have to check it from modules, because all 3 are different interfaces. So you have to check it at all the 3 places. And then out. Okay. Check out for development, wait for a moment, exit test script, yes. So there is one more thing that we have to do in the test script that I forgot to put in here. That is in insert. Here you have to do DMESG. So you can see the messages given by your device driver in the kernel log buffer. That's it. I'll run the test script once again. Okay, 1 for check-in, 2 checkout for development, 3 build, done properly, 4 insert your driver, DMESG. It shows you begin, major number is 238, end. Press enter. You want to remove your driver, 5. Driver is removed, and you see cleanup function begin, cleanup function end, and no errors reported in between. That's out. Now number 6, checkout for development. Here we are. All the files have been checked out for development properly. And now number 0 is exit the script. Okay, we need to put in the echo command for every function, because otherwise empty echo. Everything is mixing up in the display. That's fine. Let's go back to our device driver now. Initialization. So you have done initialization in the last class using registered CARDAV, and if you remember, I told you this method is now old. We are doing kernel number, we are using -R, which is the latest version, 5.10.22, which was released on 11th of March. So usually the device drivers developers, usually they use a kernel which is at least 2 years old. But in this training, I have taken the latest one. The reason is new issues, new bugs, new challenges will come. So we will address it right here in the classroom and try to resolve those issues. Thereby, we'll be one of the most updated people in this world for device driver development for the latest version of kernel. Okay, so let's go to init function. Registered CARDAV is old. Now you have better new interfaces. Let's go to the kernel headers. User, src, kernel version, include, Linux is the path where you get kernel headers. Here you have fs.h. In fs.h, you will find the new interface called alloc CARDAV region. We will use alloc CARDAV region from today, which is a new interface used in the latest kernels. Now what does it do and how does it work? Alloc cat region. Just like before, used to register the character device driver with the kernel. Used to register character driver with the kernel. Okay. जगजीत नहीं क्या? हाँ जगजीत है. Now let us look at this. What does it do? Very first thing about this dev underscore t pointer. So it's a pointer to dev underscore device ID. We won't give the device ID number. It's output parameter. Means once the device driver is inserted and connected successfully with the device table, the device ID, major and minor number, both will come and get listed in this. This is dev underscore t. This will be containing the major number and minor number. You know, this is 12 bits and this is 20 bits. Okay. Then you have this number here. This is first minor number. First minor number. What is first minor number? Well, there could be many devices. Connected through single driver. Like from USB, you can connect touchpad, you can connect camera, you can connect keyboard, you can connect external drive, pen drive. So many things you can connect with a single driver. Okay. So all those devices will be connected through a single driver, n number of devices connected through a single device driver. But all n number of devices will have their own minor numbers. Okay, so what will be the beginning of those minor numbers? First minor number only. Suppose you have 5 devices, you want to give minor numbers 0, 1, 2, 3, 4. So 0 is the first number. But you want to give the minor number 1, 2, 3, 4, 5. So 1 is the first minor number. So this is the first minor number only. Okay. Then you have this. This is number of devices. That will be connected from the given device driver. And this one is the driver name of the device. Okay. Now this alloc character region returns what? the return value is extern int. Returns major number. No, sorry, return 0 for success. Or -1 on failure. ठीक है. So let's try alloc kind of region. Corresponding to alloc kind of region, you have to use unregistered kind of region in the cleanup function. Unregistered kind of region. Unregistered kind of region. It is used in the cleanup function for unregistering the device driver from the kernel. And remove entry from device table. Okay, it takes the device ID and number of devices. This is device ID containing both major number and minor number. And this is number of devices. आवाज क्लियर नहीं आ रही जो भी बोल रहा है. नंबर ऑफ, आवाज क्लियर नहीं आ रही, फिर से बोलना. हाँ, that is also used. That we'll see. Okay, so let us use alloc cadre region and unregistered cadre region in the initialization and cleanup functions correspondingly. Now, here we are first in the initialization function. I am going to use alloc cadre region now. Alloc cadre region. So first was device ID. Device ID was a pointer to dev_t. Let's declare dev_t variable in the declarations.h. You have to declare extern variable called dev_t type. Let's call it dev ID. Then in the initialization function, you have to, that was the definition here, you declare dev_t type variable called dev ID. Okay, now you can use this dev ID here. Address of dev ID because it wanted a pointer. Second argument was first minor number. So the first minor number has to be declared like this. You declare the macro called minor number define external variable also called minor number, and then declare this variable as global. Okay, and then initialize this variable to its initial default value, which is 0. After that you can use minor number as the first minor number, which is 0. Then next you have to give here is number of devices. So let's declare a variable default initial value for number of devices. The default initial value for number of devices will be given like this: number of devices, say 1, at least one device will be there. So declare this value, define this value here as external, then declare it as a global value here, then use this number of devices here, and then finally you give the device ID. Look at this file operations which was used earlier. You remember the file operation structure that we used earlier here. This file operation structure was anyway empty. Later on it was realized that the file operation structure is anyway empty. Why using an empty file operation structure? It was not required. Therefore it was removed. So the file operations.h that we have been using earlier is now commented and is not used. Okay. So the return value of alloc CADAV region will be 0 for success. So let's capture the return value in a local integer variable called return value. Okay. In a variable called return value, which is a local variable. We missed it. We have to initialize number of devices also. There it is. So we'll check the return value for -1. If it is -1, then we'll give the message alloc CADAV region failure. Go to out. Otherwise we have to display the major number. You can't display the major number now like this, because the major number is not in the variable major number. Instead the major number is inside upper 12 bits of dev_id. Upper 12 bits of dev_id. Okay. Here, dev_t. The upper 12 bits of dev_t. The upper 12 bits of dev_t contains major number. Okay. Now to extract this major number, you will be using a macro called major. And you will give as argument this major number, this dev_t variable. This. Okay. Now what it will do is this. It's a macro. Okay, it will extract upper 12 bits from its argument, comma, convert it into integer and return. Okay, this is how we'll be able to get the major number is equal to major macro, in which you'll give dev id, a variable of type dev underscore t, as argument, major macro. Similarly, minor number will be obtained from another macro called minor, which will fetch the lower 20 bits from dev underscore t type variable, convert it to integer and return it into a variable called minor number. Now you will be able to display both major number and minor number like this. Okay. Similarly, we will have cleanup function here. Instead of registered char dev, unregistered char dev, we'll be using unregistered char dev region. Okay, in which we have to give two arguments: the dev underscore t variable and the number of devices. The dev underscore t variable is called dev id and number of devices. That's it. Okay, let's try this driver now. If everything goes well and our driver is compatible with the latest version of the kernel, then we will be able to insert our driver successfully. One check-in. Declaration. What did we do here? Declared, defined. Defined external variables like minor number and NOD. Clean function. Unregistered the device driver using unregistered char dev region. Init register driver using alloc char dev region. Extracted major number and minor number from dev underscore t type variable using major and minor macros respectively. Displayed major and minor numbers. That's it. One check-in. Can we? 2 checkout for build. 1 check-in, 2 checkout for build, 3 build driver, and there are no bugs, everything is working perfectly fine. 4 insert the device driver. There it is inserted right at the top. CD150 cat/prod/devices. The driver number 238 is yours. The module stack should show your driver at the top. There it is. DMSG gives you major number and minor number separately. Did you see that? The major number and the minor numbers given separately. Then you have to remove your driver, choice number 5. We removed it. You see from the top of the list of modules your driver is gone. From the device table 238 number entry gone, so removal is successful. From the modules stack also your driver is gone from the top, and you see the cleanup function executed, begin end, no errors reported, and your driver is out. Okay, 0 for exit. Now we have to create a log script for you. In which we will create the file. File name is equal to backticks touch file name. The file name is log dot date command with arguments year, month, day. Okay. So let's see if it works. Log script. Then after that, in a loop for value stored in main, where in ls star dot h comma v dollar ls star dot c comma v do you will do rlog from file name and append it to file called file name, and the whole log will be created. Let's run the log script. Some bug. Yeah. Still there is some bug. 7 R log ambiguous redirect. Not needed. तब तो FILENAME फाइल नेम हो जाएगा, तो फाइल नेम हो जाएगा. File name is not getting printed, surprisingly. Instead there is an empty line. But then if the file name is not created, then how is it that the file name is displayed here? It's highly surprising. The file name is getting created properly. That's why the file name is getting created, and rlog is not happening because the file name is created. You can see the file name, that the file name is here. You have the file name here. No, this was created earlier, and let me remove this. So you have only one file that is getting created, and that is this only. So this file is getting created, but when I display it, it is not getting displayed. Due to which there is some problem happening here. So I'm out of time. What I'll do is I'll resolve it later and send the log script to you in the discussion forum. Okay. There is some flaw in this, so you have to see that. Fine. So that's all I got for you today. You update your device driver and bring it to